was an operations manager at a busy airport catering warehouse dispatching 320 carts per day. Cart staging used a spreadsheet with 14 status codes, radio calls, and handwritten bay changes, causing frequent searches and missed aircraft handoffs. I needed a simple solution that worked for drivers, loaders, and planners without commissioning a 6-month software project. I considered buying tracking hardware, simplifying the spreadsheet, or replacing coordination with a physical and digital 3-state flow. I mapped 30 cart journeys, timed searches, and asked each role which decisions they actually made. 11 of 14 codes conveyed history but changed no action. I reduced the process to build, ready, and released, assigned fixed color zones, printed one scannable card per flight, and built a small dashboard from existing scans. Planners feared losing exception detail. I retained a reason field only when a cart could not advance and gave them an exception view separate from frontline execution. The first layout placed 2 similar flight numbers beside each other. After a near miss, I changed zoning by departure wave and added a verbal flight check at release. I also documented the operating assumptions, named the owner for each follow-up action, and set a clear review date so that temporary controls could not quietly become permanent. I wrote the decision, assumptions, owners, and stop conditions on a 1-page control plan so the next shift could challenge the logic rather than rely on verbal context. I used both a leading indicator and a customer outcome measure that prevented a short-term productivity improvement from hiding quality, safety, or backlog age. During implementation, I stayed at the operating point for the first cycle, asked frontline employees what the mechanism missed, and changed only one variable at a time. I assigned named owners for each checkpoint and made escalation thresholds visible in the shift huddle, which reduced ambiguity when I was not physically present. After stabilization, I compared the result with the original baseline, checked for cost or defect displacement, and documented the mechanism for the other shifts. Before committing, I asked a supervisor who disagreed with me to identify the weakest assumption, then converted that concern into a measurable checkpoint rather than relying on consensus. I separated mandatory controls from preferences, which let the team move quickly without weakening the safety, quality, or customer promise that the operation existed to protect. For each alternative, I estimated the likely customer impact, labor requirement, operational reversibility, and worst credible failure, and I explained why my chosen path offered the best balance. I briefed affected teams before launch, checked understanding through questions rather than attendance, and made the escalation route clear to people working outside my shift. I also protected normal operations by defining which work would pause, which work would continue, and who could authorize expansion beyond the initial controlled scope. At every review point, I compared actual performance with the assumption that justified the decision. When they diverged, I changed the plan rather than defending the original recommendation. I made the cost of the choice visible as well as the benefit, because hiding overtime, rework, or displaced backlog would have made the result look stronger but less useful. Once the immediate issue was resolved, I held a short review with frontline representatives and partner teams, captured what failed in the original mechanism, and assigned permanent actions. The follow-up remained on my weekly operating review until the control had an owner, an auditable measure, and enough stable data to show the improvement was sustained. That discipline helped distinguish correlation from causation. I looked for the expected change at the affected process step before crediting the intervention for the overall outcome. Average search time fell from 11 minutes to under 2, missed handoffs dropped from 9 a month to 1 in the next quarter, and radio traffic fell 46%. Adoption reached 100% without new hardware. Before closing the action, I sampled performance across different shifts and demand conditions, so the result did not depend on one unusually experienced team or a quiet operating window. Simplification starts by identifying the few states that change action, preserving exceptions separately, and testing the solution where work physically happens.